Welcome back students to Alchemy online class. In previous class we learned about the pressure exerted by fluids, that is by liquids and gases, and we started with the atmospheric pressure. I hope that you have done the homework, you have drawn the diagrams which were given in homework. Now we will see atmospheric pressure in detail. The pressure exerted by air on an object is known as atmospheric pressure. Atmospheric pressure on the Earth's surface at the sea level is 100,000 Pascal. We can write it down this way, 100 kilopascal. This atmospheric pressure is so enormous, then also we are not feeling it. Suppose the area of our head is 15 centimeter into 15 centimeter, then how much weight of air are we going to feel? The weight will be 225 kilo, which is equal to 2250 Newton. This weight is equivalent to the weight of 2 baby elephants. So enormous weight we are feeling on our head, then also we are not getting crushed down against the atmospheric pressure. Why is it so? It is because the blood in our blood vessels exerting pressure and the fluids which are present in our body, they are also exerting pressure. So the pressure of the blood in the blood vessels and the fluids in our body are balancing the atmospheric pressure. Because of this reason, we are not feeling the air pressure, atmospheric pressure on our body, and we are not getting crushed down against it. And the atmospheric pressure is measured using an instrument called barometer. See the next image, which is showing the barometer. Atmospheric pressure of a place depends on its altitude. Altitude of a place is the height of the place above the sea level. As the altitude increases, the atmospheric pressure decreases. At higher altitude, the atmospheric pressure is lower. So that's why when the mountaineers are going at a height on the higher altitudes, when they are going, sometimes they are having nose bleeding. Because the difference of the air pressure, the blood vessels are bursting out, and that's why the nose bleeding is seen in them. When the astronauts are going into space, they are wearing a special types of pressurized suit, because in space there is no air and the body is exerting pressure, the body fluids. So that's why to overcome that, they are wearing the special types of suits. Now we are going to learn about the applications of liquid and atmospheric pressure. At the bottom of the sea, the pressure is much greater than it's at the surface. That's why the deep sea divers are using the special suits when they are going inside the sea, and this is preventing them from being crushed by the pressure at the bottom. Another example is of a rubber or plastic suction hook. This rubber or plastic suction hook is pressed tightly against a smooth wall or a tile, and it is not coming out from there. It is because when it is pressed hard on the walls or a tile, the air between the sucker and the suction hook and the surface will expel out, and the outside pressure is very much greater there, and that outside pressure is keeping that hook firmly on the wall, that smooth wall or the tile. See the picture of this suction hook. The third application is a drinking straw. When you suck the air inside the drinking straw, at the time it reduces the pressure inside the straw, and the outside atmospheric pressure allows the liquid or forces the liquid to move inside the straw. That's why we are able to drink the liquid through a straw. On the same principle, our syringe works. When the syringe is inserted, the needle of the syringe is inserted in the body, and when the plunger is pulled out, it creates a low pressure inside the syringe, and the liquid or the blood is exerting a very great pressure, and it forces the blood to come out inside the syringe. The another application is a vacuum cleaner. A vacuum cleaner is having a fan inside it which lowers the air pressure inside the device, and outside the pressure is more, which is allowing the air and the dust particles to go inside the device. So these are the applications of liquid and atmospheric pressure. This is the end of this chapter. In today's class, we learned that atmospheric pressure on the Earth's surface at the sea level is 100,000 Pascal. It is measured using an instrument called a barometer. Then we learned its applications. And now we are going to start the textbook exercises. The first question is, give 2 examples each of situations in which you push or pull to change the state of motion of objects. Here you have to give the 2 examples of the examples in which the push is used and 2 examples in which the pull is applied on the object. The first one, in push, the first example is a heavy box. If a heavy box is to be taken in the another room, then it has to be pushed. So when we are pushing the heavy box, it is changing the state of motion of the heavy box. And the second example is the football. The football, when a player is kicking the football, he is pushing the football and it is changing the state of motion of the ball. Now we will discuss about the pull. The first example is drawing water from the well. When we are drawing water from the well, we are pulling the rope and it is changing the state of the motion of the bucket. The another example is opening a drawer. When we are opening a drawer, we are pulling it out, and at that time the state of motion of the drawer is changed. The second question is, give 2 examples of situations in which applied force causes a change in the shape of an object. Here the 2 examples are, there are many examples, but 2 examples I am giving here. The first one is squeezing of plastic bottle. When you squeeze the bottle, it is changing the shape of the plastic bottle. And the another example is kneaded floor. When your mother is kneading the floor, at that time also the floor is changing into, the shape of the floor is changed, and then from the kneaded floor, she is taking some amount of the floor and she is making it round, and then she is making the roti. At that time, it is changing the shape of the kneaded floor. So these are the examples in which when the force is applied, the shape of the objects change. This is the end of today's class. We will discuss other questions of the textbook in the next class. Before we end up the session, it's time for today's homework. The homework is do textbook exercises number 3, 4 and 10. I hope you will write these exercises in your notebook. We will meet once again in the next class. Till then, be safe, be at home and keep learning.